Inside Building Products, a Siemens podcast that keeps you learning.
Welcome to the Deep Dive. Where your shortcut to, well, genuinely understanding complex stuff, hopefully with a few surprising facts, and just enough humor to keep you listening. Today, we're pulling back the curtain on something you interact with constantly, probably without even thinking about it. It's the hidden, but really essential world of valves and actuators in our buildings.
Yeah, we've dug into some really great source materials, specifically some videos from the Siemens Building Product Academy, and we've pulled out what we think are the key takeaways for you. So our mission today, pretty clear. We want to break down these crucial components, make sense of how our buildings, stay comfortable, efficient, and perfectly regulated. And we're going to try and do this without getting totally lost in technical jargon. The focus is really on the impact these invisible heroes have on your day-to-day life.
Right. And if you really want to get a handle on why valves and actuators are so important, maybe imagine a building like human body. Think about how your body takes food, converts it to energy, right? And then it carefully sends that energy exactly where it needs to go. Okay, yeah, I can picture that.
Well, a building does much the same thing. It takes energy maybe from renewables, maybe fossil fuels converts it, and then distributes it across different areas, different zones. In our bodies, veins and blood handle that distribution. It's a complex network. In a building, it's usually water flowing through this whole system of pipes. And here's the fascinating bit. The valves and actuators, they're the devices making sure the right amount of water gets to the right place.
At the right time.
Exactly, at the right time. They're absolutely critical for the building's overall energy efficiency. They directly impact how much energy gets used just keeping you warm or cool. I mean, without them working properly, a building would just be constantly fighting discomfort and, frankly, wasting a ton of energy.
That's a really powerful way to put it. It makes their role instantly understandable, even if you've never thought about building mechanics before. So just to hammer home that body analogy for you, our listener, these small, often forgotten devices, they're basically the building circulatory system, working away quietly to make sure everything runs smoothly, precisely. But let's dig in a bit. How do these tiny titans actually do that? How do they achieve that precise control? What are we talking about here, tech-wise?
Exactly. They're constantly adjusting moment by moment. And when you look at companies really leading the charge here, a great example of this kind of versatility and precision is the Actuators portfolio from Siemens. These aren't just, generic bits of kit. They're designed with really specific things in mind. They need to be easy for installers to use. They have to offer the highest possible control accuracy and, of course, be super energy efficient. The Actuators range is pretty broad. It covers basically every part of a building's climate control. That's your HVAC systems, heating, ventilation, air conditioning, everything from generating the heat or the cold to distributing it and then getting it exactly where it needs to be in a room or a zone. Yeah, it might seem a bit counterintuitive now, when everything's about convergence, but buildings are just so diverse. Think about a high-precision lab versus a huge apartment block. You just can't have one master valve that does everything perfectly for both. The key thing here is specialization, really. Understanding that if you optimize for one thing, say speed or pressure handling, you often need a dedicated solution. So selecting the right valve becomes this interesting balancing act, trying to get the best performance for each specific job.
Okay, so the complexity of buildings really means you need this wide range of tools, these different valves, but you hinted that it's not just about simple mechanics anymore, right? Are we seeing valves getting smarter, almost predicting what's needed instead of just reacting?
Yes, you've absolutely hit on something crucial there. While those basic valve types are still, fundamental, the dynamic valve is really emerging as the technology of the future. And for someone who isn't an engineer, the real breakthrough with these isn't just small improvements. It's a complete shift in how we handle building hydraulics. Basically, they get rid of the need for those incredibly complicated hydraulic calculations, the ones that used to give engineers and installers major headaches.
Really, no more complex calculations.
Pretty much. Think about it. Instead of pages of equations and, hours of figuring things out, the selection process gets way simpler. You mainly just need to know the volume flow needed. The valve handles the rest. This also makes installation much easier because you don't need all those extra flow regulating or balancing valves cluttering things up. The dynamic valve does those jobs internally. Commissioning, setting it up on site, super easy. Yeah. Simple presetting for the maximum flow, and it balances itself automatically. But the really killer benefit, Dynamic valves give you balanced water flow under all conditions, all load conditions, which means they basically eliminate those annoying room temperature swings that nobody likes.
Ah, the hot and cold spots.
Exactly, and the impact you can measure. They can genuinely cut a building's energy use by up to 30%, and that's without making anyone uncomfortable.
Wow, 30% energy saving without sacrificing comfort. That's huge. That really is a game changer for anyone managing a building or even just living or working in one. So how does that actually feel day to day for someone running a big office building or apartment complex? Can you give us specific examples? What do these dynamic marvels look like?
Oh, absolutely. Let's talk about two key examples in the dynamic valve world that are making a big impact right now. First up, we have intelligent valves. This was Siemens' first self-optimizing dynamic valve. And here's the really cool part. It's cloud connected.
Cloud connected, so it talks to the internet.
Essentially, yes. Imagine a valve that can not only think for itself, but also communicate. It's constantly learning, predicting, adjusting based on data. It shifts things from just reacting when something's off to proactively managing efficiency. It's always optimizing energy use, boosting the building's overall performance, and that obviously brings down running costs significantly. The real step change here, it's not just about saving a bit more energy. It's fundamentally changing how we manage energy and comfort. It's not just saving money, it's about making our buildings truly ready for the future. Intelligent valves bring benefits across the whole life of a building system. They make work simpler, save time, ensure people are comfortable, and seriously boost energy efficiency. They're really transforming how buildings operate.
Okay, self-optimizing, cloud-connected. That's pretty advanced stuff. What was the second example?
Right. The second one is PICVs. That stands for Pressure Independent Control Valves. Now, these are also dynamic valves, and their main job is simplifying the hydraulics, but in a really smart way. So you might ask, what's the big deal about PICVs? Well, they make the day-to-day work much easier for building operators. They significantly increase comfort for occupants, getting rid of those hot and cold spots we mentioned, and they actively cut energy costs.
How do they do that? Simplify hydraulics, I mean?
Think of a PICV as like a smart tap. It doesn't just turn water on or off. It automatically guarantees you get the exact flow you asked for, no matter if the pressure changes somewhere else in the pipe system. It bundles several key jobs into just one valve body. You've got the control valve part, a way to preset the maximum flow, a differential pressure controller, which shields it from pressure swings, and even points to measure the pressure. All in one.
All integrated.
Exactly. So constructed, PICVs automatically optimize the hydraulic flow, boost comfort, and save energy. And it's interesting, Siemens was actually the first company to bring PICVs to the market. Shows their sort of innovative thinking there.
It really is incredible how much these dynamic valves, like the intelligent valves and PICVs, can automate and optimize. It definitely sounds like the future of managing buildings. But I guess not every single situation or every part of every building needs a super smart cloud-connected valve, right?
Right.
What about the other kinds, the ones maybe doing simpler jobs?
You're spot on. Dynamic valves are fantastic, very impressive, but you absolutely need a full range of solutions for all the different jobs out there. While dynamic valves are, the future for many situations, we can't forget the sort of foundational workhorses that are still essential in countless systems.
Like what, for instance?
Well, take globe valves. They're kind of the everyday heroes for solid general flow control, probably the most common type you'll find in HVAC. And Siemens has a huge range of these, with actuators to match for all sorts of different technical needs. Then you have control ball valves. These use a sphere, a ball inside, to control the flow. They come in 2-way, 3-way, even 6-way versions, which gives you amazing flexibility for directing water in different ways.
6 ways.
Yeah, pretty versatile. And installers often really like them because of one particular feature. You can attach the actuator to the valve without any tools, and it's incredibly fast. Record-breaking quick, actually. Saves a lot of time on site.
Installers would love that.
Definitely. Then, for jobs that need real speed and very fine control, there are solenoid valves. These are the fastest valves around. They allow for incredibly precise regulation, almost down to the droplet, you could say, that leads to maximum efficiency and really stable control. They're perfect for high-demand situations, even tough industrial settings, like, say, engine test benches, where you need extreme precision and super fast response times.
Okay, so very specialized.
Very. And finally, you've got rotary valves. These are generally for simpler on-off switching or basic mixing tasks. Straightforward, reliable performance. So you see, with a portfolio like Actuators, you really do have everything covered. Whatever the specific need, whatever the complexity level, there's likely a solution.
That really does give a full picture. from the basic workhorses to the super smart ones. So let's bring it back to the listener. What does all this mean for you? Maybe you manage a building. Maybe you just want to understand how these places work so well without you noticing. It sounds like these devices offer real, tangible benefits, not just, abstract technical stuff.
Absolutely. The advantages are very real, and they show up in lots of different situations. Because the portfolio is so broad, Actuators can tackle many specific real-world challenges. For instance, think about industrial environments, places where water flow and temperature need super fast, super precise control. Those powerful solenoid valves we mentioned, they're the perfect answer there. Or consider really extreme conditions, like in district heating networks. You're dealing with incredibly high temperatures, high pressures.
Mix of conditions.
Exactly. You need really robust hydraulic actuators to control the valves in that situation. Siemens offers those, and honestly, they're almost unique in the market for how well they perform under that kind of stress. And then even just thinking about the room level, especially in places with big weather swings, boiling summers, freezing winters, you constantly need efficient dynamic balancing of the whole water distribution system just to keep things comfortable. For that, Siemens recently brought out a pressure-dependent 6-way control valve. It's basically a switching valve, but with dynamic functions built in. That's something hardly anyone else offers right now.
So that specific expertise really translates into advantages for the customer.
Precisely. Customers definitely gain a lot through this kind of specialized knowledge and innovative products that come from it. Better comfort, higher efficiency, and simpler operation.
Well, this has been incredibly insightful, a real deep dive into a world most of us probably never give a second thought to. So to loop back to that brilliant analogy you started with, we've learned valves and actuators are basically the building's circulatory system, making sure everything flows just right, like blood in our bodies. We've seen how a versatile range like Actuators offers solutions that are user-friendly, precise, and energy efficient for pretty much all HVAC needs. And crucially, we've highlighted those dynamic valves, especially intelligent valves and PICVs, as really the technology of the future, simplifying things, making us more comfortable, and saving significant energy. So maybe next time you're in a building that feels just right, not too hot, not too cold, remember those unsung heroes, those small but mighty components working away behind the walls, making it all happen.
And maybe one last thought. If we connect this to the bigger picture, think about how the increasing intelligence, the self-optimization, the cloud connectivity of these essential building parts, how might that reshape not just how much energy we use, but the actual way we design our buildings, how we interact with our living and working spaces in the years to come? Could our buildings become truly responsive, almost intuitive partners in our daily lives? Something to think about.
That is a really thought-provoking question to end on. Thank you for joining us on this deep dive. Keep exploring the hidden tech that makes our world tick.